In 2025, physicists released new data suggesting our universe may actually be a hologram, an encoded projection from a deeper reality we cannot directly see. To be clear, this is not confirmed fact. Researchers published new tests and theoretical work that make the holographic idea more testable, not a settled conclusion. If the holographic model proves useful, then sites across Earth long spoken of as portals could represent locations where such a projection might display measurable anomalies. That possibility frames our path forward. We'll look at cutting-edge physics, revisit ancient portal sites with recent measurements, and review what governments have finally put on record. And it begins with the renewed question: are our lives unfolding inside a holographic projection? The Holographic Universe revisited in 2025. By 2025, the holographic principle was no longer just a provocative idea. It had become the subject of new theoretical work and concrete proposals for experimental tests. Teams of physicists developed ways to probe whether the universe's information patterns behave like a hologram at scales laboratories can actually investigate. A paper in Physical Review Letters put forward predictions that, in principle, might be checked with particle experiments or astrophysical data. What was once dismissed as metaphor now has testable footholds, marking a major shift in how scientists frame the question. The foundation of this idea traces back to black hole research. In simple terms, black holes were once thought to erase information completely, but careful models revealed something surprising. The information about what falls and seems to be encoded on the boundary, the event horizon. This observation sparked the holographic hypothesis. Information might be tied not to the volume of space, but to its surface, much like how a two-dimensional film encodes a three-dimensional image. That clear boundary analogy remains one of the strongest motivations for viewing the cosmos in holographic terms. Other developments have added to this momentum. Quantum entanglement, long the most baffling feature of quantum mechanics, has seen rapid experimental progress. In 2025, new tests reached precision levels that were once impossible. Entangled particles continue to show instantaneous correlations across distance. Importantly, this does not allow faster-than-light communication, but it does keep highlighting cracks in our classical notions of locality. These correlations now stand at the center of thought experiments about quantum gravity and holography. Research groups, such as those at Caltech, have used controlled quantum simulations to model communication across entangled environments, scenarios that mathematically resemble wormhole-like links. These are not literal, traversable wormholes through space, but they provide valuable analogs of how information might move in a holographic system. One question raised by these studies is whether the projection, if it exists, ever shows signs of strain. In digital systems, code can glitch at boundaries. In 2025, computer scientists working with simulated physics models found something striking. The digital universes they coded sometimes produced boundary instabilities. Rules interacting across different simulated zones generated defects that appeared as temporary corridors. Regions where simulated matter duplicated or briefly slipped across coordinates before stabilizing again. Engineers described these occurrences as glitch boundaries. While entirely artificial, the resemblance to descriptions of hidden doorways in Folklore sparked attention, making what was once myth feel more like a useful analogy. At the experimental front, particle physicists continue to search for subtle patterns. Some high-energy experiments, including runs at CERN, registered low-level field anomalies in late 2024 and early 2025. These did not match expected noise completely, though they were slight and irregular. Teams emphasize they do not imply portals or any external projector. Instead, they treat them as early hints, statistical features that need thorough checking before any claim can be made. The main point is not that a hidden machine is flickering behind the curtain of space, but that certain results show unexpected shapes in what should be smooth distributions, prompting further testing. The convergence of these lines of inquiry, black hole boundary encoding, entanglement correlations, anomalies in simulations, and cautious physical measurements, forms the renewed picture of the holographic universe in 2025. This is not speculation untethered to data. It is a framework where multiple research fields keep pushing in a similar direction, suggesting reality may be structured more like a coded field than inert material. Each new paper, workshop, and experimental run is sharpening the claim into hypotheses that can be falsified in a laboratory. What makes this turn more intriguing is how it intersects with human history. If a projection can thin in certain conditions, then some physical places on Earth might register more anomalies than others. Scientists speculate that environments combining strong magnetic fields, gravitational stresses, or unusual rock formations could, in principle, emphasize these thin spots. The cautious suggestion is that ancient cultures who built monuments at such sites may have noticed strange phenomena, shimmering visions, sounds, or electric disturbances, that were later preserved as stories of gateways and gods descending through stone doors. Today, research groups are starting to map subtle spikes in electromagnetic data against geography, charting where anomalies do and do not recur. This methodical work aims to test whether sacred sites align with unusual field measurements. If some coincide more than chance would allow, it would strengthen the suspicion that our ancestors encountered something measurable, even if they did not describe it in modern physical terms. The renewed debate on the holographic universe is therefore not confined to blackboards and particle detectors. It seeps into broader conversations about how science intersects with old narratives. The mathematical frameworks suggest information is encoded on boundaries. Entanglement reveals non-local correlations that align with holographic thought experiments. Simulated worlds display natural glitch effects at their borders. High-energy labs report faint field variations under controlled conditions. Taken together, they paint a picture where the universe may not only be holographic in principle, but also show weak points where that structure becomes less stable. And that raises a more concrete question. If instabilities exist, where would they leave signatures we can actually detect? Theoretical work is abstract, but surface features, rises in magnetism, distortions in electromagnetic fields, even subtle alignments of rock and resonance, might provide physical markers. Cultures across the globe often focus sacred architecture on specific sites, and many of those sites continue to show faint, but unusual measurements even today. This merging of physics and archaeology sets the stage for what comes next. Beyond the formal models and data points are landscapes where people reported encounters at carved stone gates, vast temples, and mountain passes held sacred for centuries. Researchers now approach them not only as historical mysteries, but as locations where our world might display the very boundary effects that holography implies. Some of the most compelling examples have only recently shown measurable anomalies, keeping alive the possibility that those ancient accounts were responding to something real. Disturbances in the projection itself. Ancient portals and the Gate of Aramu Muru. In southern Peru, beside the high plateau of Lake Titicaca, a single rock face holds an unusual carving known as the Gate of Aramu Muru. The feature is striking, a tall rectangular outline surrounding a smaller recessed niche, resembling a doorway that leads nowhere. For local communities, it has long been regarded as a sacred marker woven into Aymara oral tradition. For travelers and tour guides, it is a magnet for legend. What gives it renewed interest today are the scattered, though unverified, claims of anomalies reported in its surroundings. In 2024, several independent survey teams, most linked to local tourism networks and popular press outlets, claimed they had used ground-penetrating radar and pulse imaging on and around the site. According to their reports, the scans hinted at possible cavities or voids beneath the rock, arranged in odd directions. Some of these channels, they suggested, even seemed to line up with astronomical orientations. Yet it is important to stress that these reports do not appear in peer-reviewed publications and have not been confirmed by formal archaeological excavation. Mainstream archaeologists continue to treat Aramu Muru as an enigmatic carving, but not as verified evidence of hidden chambers or engineered structures. Alongside these radar stories came another round of claims. Portable magnetometers allegedly picked up small fluctuations in the local field, clustering near the recess itself. At certain times, visitors reported that instruments spiked briefly before returning to baseline. While these claims circulate widely in travel accounts and paranormal reports, they remain unconfirmed by published geophysical surveys. Archaeologists and geologists note that natural variations in highly mineralized rock can easily produce background effects that confuse portable gear. The result is that, for now, any talk of consistent magnetic anomalies must be treated as anecdotal. Despite this lack of academic confirmation, Aramu Muru remains powerful in popular imagination because of the surrounding indigenous traditions. Aymara stories recorded across decades of interviews and travel literature describe the niche as a door to the gods. Accounts tell of beings of light or great priests who entered the stone recess and vanished, returning when they chose. Other versions speak of rituals performed with drums or flutes, music whose vibrations opened the doorway. One soundbite, often paraphrased by guides, captures the mood. The gods walked into the stone as if it were water and crossed over. Immediately after retelling this tale, it is critical to add the caveat. These are oral traditions, passed through generations, and they remain a matter of culture, not scientific measurement. But they continue to draw seekers who hope the gate is more than symbolic. When viewed in a wider context, the motif of false doors and carved gateways repeats across distant cultures. In Bolivia, nearby monoliths carry etched door-like forms that open to no chamber. In Egypt, painted facades on tombs symbolize thresholds the soul might cross within the afterlife. In India, temple traditions recall sealed doorways guarded by divine decree, reserved for times yet to come. Each example is rooted in a distinct cultural framework, yet together they suggest a recurrent theme, shaping stone to echo the idea of portals. For skeptics, this is metaphor. For more speculative interpreters, such repetition may point to traditions formed around natural phenomena, subtle forces only felt, not measured. Returning to Aramu Muru, those who support the anomaly claims highlight reports of readings shifting during periods of intense solar activity. Witnesses assert that in 1 week of 2024 solar storms, handheld magnetometers showed stronger disturbances than usual, appearing to line up with satellite observations of the ionosphere above the region. Yet here again, the qualifier is essential. These observations have not been officially confirmed by large-scale scientific campaigns. Independent researchers emphasize the need for controlled, published surveys to separate meaningful effects from normal geomagnetic turbulence. The landscape of Lake Titicaca adds its own variables. Geophysical studies, not mainstream portal theories but standard surveys, do show that the Altiplano is marked by small gravity anomalies, with rises and dips across the basin. These features often result from subsurface density variations caused by volcanic history and tectonics. For local communities, however, such regions have long felt different, provoking sensations of dizziness or disorientation. Stories of sacred spots are sometimes tied to those bodily experiences, expressed long before scientific instruments existed. The gate's placement may reflect intuitive recognition of a place that felt charged or unusual compared to surrounding terrain. The question then becomes one of intentional design. Did those who carved the recess deliberately choose this rock face because it seemed distinct in sound, orientation, or physical sensation? If so, the door may have signaled a focal point for ritual engagement with forces they perceived but could not record. Rather than an inert niche created at random, it might have functioned as a marker for experiences they regarded as contact with other realms. Within that perspective, legends of beings stepping through stone might not describe ordinary architecture, but perceptions shaped by complex environmental conditions. While independent teams and storytellers continue to promote the site as an actual portal, mainstream archaeology maintains caution. As of 2025, no peer-reviewed excavation has revealed subterranean chambers, nor has any reproducible geophysical study substantiated claims of magnetic rifts. Scholarly consensus remains that Aramu Muru is a remarkable carved surface embedded in ritual landscape, its true cultural meaning still being explored. For those fascinated by the paranormal, it becomes a candidate for projecting theories. For researchers committed to empirical tests, it remains in need of systematic study. This balance between legend and measurement is what keeps Aramu Muru compelling. On one side are stories preserved by the Aymara and echoed in spiritual tourism, a gateway where music, ritual, and devotion could open access to another dimension. On the other side is the scientific need for controlled, published data before granting any claim. The contrast itself sustains the mystery. It is not that the stone gate has yielded empirical proof of a breach in reality, but that it continues to sit at a crossroads, where persistent cultural memory coincides with sporadic claims of instruments behaving strangely. Seen through this lens, Aramu Muru does not prove the existence of a holographic projection or interdimensional passage. It does, however, illustrate how natural landscapes, ritual markings, and oral traditions converge to create powerful sites of interpretation. When small anomalies, whether real or misread, overlay a background rich in story, a place becomes charged with meaning far beyond its physical form. That is why the rock face continues to attract expeditions, spiritual seekers, and scientific curiosity alike. As scanners, instruments, and legends all accumulate around this single recess in stone, the unavoidable next question is how people respond when such sites appear to exert more than symbolic influence. Beyond carvings or field readings, there is the human element. Those who visit, perform ritual, or in some cases vanish. Reports from recent years suggest that behaviors and events around reputed portals do not always end with photographs and stories. Sometimes, they end with unexplained absence. And it is here that the story takes a darker turn. Disappearances and mysterious rift cases since 2020. Since 2020, scattered reports have emerged that link missing person cases with locations already associated in legend with hidden gateways. While disappearances occur under ordinary circumstances every year, what fuels attention in these particular reports is how often they involve regions long identified with unusual geomagnetic readings or ancient portal traditions. It is important to state up front, there is no authoritative global dataset proving a rise in disappearances tied to these settings. What exists instead are anecdotal clusters, regional investigations, and public perceptions that continue to raise questions. In the highlands of Peru near Lake Titicaca, several incidents from 2020 through 2024 attracted notice because search efforts produced fewer answers than expected. In these accounts, hikers failed to return from established trails. Despite the deployment of drones, dogs, and coordinated rescue patrols, search teams did not locate belongings or footprints that might offer obvious clues. Community members in the surrounding valleys later told journalists that GPS receivers used in expeditions sometimes misreported positions in those regions, with logs showing sudden shifts of hundreds of meters before re-establishing normal readings. These anomalies remain unconfirmed by peer-reviewed studies. Nevertheless, they contribute to a growing perception that the area holds more than ordinary obstacles. For responsible investigators, the absence of physical evidence does not confirm extraordinary forces. Instead, it underscores the need to cross-check witness accounts, instrument logs, and geological conditions before reaching conclusions. A second often retold story centers on Nevada's desert canyons. In 2021, a group of experienced hikers encountered navigational trouble when their GPS devices lost satellite lock under otherwise clear skies. One member moved slightly ahead of the group and never returned. Search efforts covered wide areas, supported by helicopters and ground teams, but discovered nothing decisive. Reports from the time noted that instruments at a nearby monitoring station picked up brief disturbances in electromagnetic readings. Once again, nothing in these records proves causation. From an investigative perspective, these details are unexplained puzzles rather than evidence of a portal. Still, the combination of a disappearance tied to equipment malfunctions keeps the Nevada case circulating in discussions about modern rift zones. Siberia's Ural Mountains present another cluster of anecdotal accounts. Between 2020 and 2023, expeditions into the tundra lost contact, sometimes permanently. Rescue parties entered within days, but the severe cold meant survival without gear would have been short. No campsites or clothing scraps were recovered. What added intrigue were satellite data logs noting sharp, localized bursts of radiation roughly coinciding with some of these disappearances. Cross-comparison with solar monitoring showed no flare activity on those days, suggesting the spikes may have been Earth-based. It is important to clarify, such correlations are preliminary and not part of formal geophysical publications. They are open questions more than established fact. Investigators cautious about extraordinary claims continue to call for independent verification before linking human disappearances to energy fluctuations. A case in Peru in 2022 gained unusual visibility because the group involved carried digital logging devices. Their trackers recorded ordinary progress along a trail, then froze. The final entries showed irregular coordinates, some kilometers away from their actual position, before cutting off entirely. When teams arrived at the site, they recovered intact gear and supplies with no signs of struggle or predation. Satellites monitoring the area that same day recorded a sharp, short-lived peak in background radiation. Here the overlap between field notes and space-based instruments gives researchers a concrete puzzle to analyze further. But even in this case, the cautious phrasing matters. At present, these are unusual data fragments, not proof of interdimensional transport. When viewed together, these episodes highlight themes rather than established. Statistics. Remote landscapes, from the Andes to Nevada to Siberia, carry reputations as charged or anomalous. People disappear in remote terrain for many conventional reasons: exposure, injury, unpredictable weather. Yet when disappearances are paired with odd device readouts or local folklore, they stand out from routine accidents. It is in that convergence of legend, missing person reports, and scattered anomalies that patterns of speculation emerge. Public perception plays a significant role in how these stories circulate. In 2023, a Canadian national survey on public attitudes toward unidentified aerial phenomena revealed that many citizens not only report sightings, but also admit they are unsure who to contact with that information. That confusion fuels attention to high-profile missing person cases touched by rumors of the unusual. When people see official systems struggle with unexplained aerial reports, they become more inclined to link disappearances with the same unsolved category. These perceptions are not scientific proof, but they shape the conversation and keep interest focused on puzzle cases. For credible researchers, the guiding principle is careful verification. Best practices require correlating multiple streams of data: the physical evidence collected on the ground, the behavior of instruments before and during the event, and any third-party records such as satellite telemetry. Without all three, the line between unusual occurrence and extraordinary hypothesis can blur. The Peru 2022 case comes closest to meeting that threshold, yet even their uncertainty remains. Responsible investigation stresses what is still missing rather than overstating what is known. What remains undeniable is the persistence of the reports themselves. Journalists, local communities, and individual searchers continue to document cases that resist easy resolution. The Nevada desert account, the Siberian Ural incidents, the Peruvian trail logs, each stays alive in discussion precisely because conventional explanations have not satisfied those who investigate them. Whether the causes prove to be undiscovered natural hazards, technological errors, or something stranger, the search for answers keeps pushing outward. The debate often circles back to one question: if something unusual occurred in these regions, how would it operate? Do our instruments react strangely because the environment itself distorts signals? Or do they simply misread in rugged terrain, with human imagination filling the gaps? That ongoing uncertainty points forward to the scientific frontier. Modern physics offers frameworks involving quantum fields, wormholes, and entanglement that provide theoretical language for anomalies people might otherwise describe only as legends. These frameworks do not confirm anything about disappearances, but they offer structured ways to think about what might occur at the boundary of our measuring tools. As these unsettled case reports continue to accumulate, attention naturally shifts to how physics might interpret such possibilities. From questions about distorted coordinates to radiation spikes high above Earth's surface, the unresolved details still invite models that address what lies beneath them. And so the inquiry moves from scattered accounts on the ground toward theoretical frontiers. Could there be physical mechanisms that resemble a kind of doorway? And if so, how might our current science describe their function? Quantum physics and multiverse gateways. If physics were to explain the kinds of anomalies tied to doorway legends, the most obvious line of inquiry would lead us into quantum theory. And in recent years, that conversation has shifted from speculation in equations to controlled, testable models. This is where researchers speak of wormholes not as science fiction passages waiting to be walked through, but as mathematical constructs that can be examined in simulations. By 2025, quantum experiments had produced proof-of-principle demonstrations showing how information might transfer across wormhole-like structures under the rules of quantum mechanics. What these studies clarify is that we do not have man-made gates or macroscopic portals. Instead, we have small-scale simulations pointing to how information exchange could behave if the mathematics of wormholes is sound. Wormholes have long been described as potential bridges between distant points of space-time. For most of the 20th century, they remained little more than an idea in theoretical physics. They required exotic forms of negative energy and immense stability that equations suggested, but no technology could produce. What has changed is not the practical ability to build one, but the ability to model their properties more rigorously. In quantum computing labs, sequences of qubits are now set up to behave according to wormhole equations, and the flow of information is tracked through them. To call this an actual wormhole is misleading. What it demonstrates is that the mathematics translates into observable outcomes. It is a way of saying the theory is internally consistent when pushed through a real machine, something that was not verifiable a decade ago. A case widely cited came from work at Caltech in 2023. Physicists programmed a specialized quantum computer to simulate conditions consistent with traversable wormhole models. Within this construct, a small unit of information appeared to pass from one side of the arrangement to the other, re-emerging intact. No space-time tunnel opened in the lab, but the match between wormhole equations and data transfer proved valuable. It showed that these strange mathematical entities are not arbitrary. They can manifest as consistent rules in working systems. The excitement lies in the fact that for the first time, wormhole frameworks generated measurable effects in the laboratory, even if only at the level of encoded bits inside qubits. Other lines of physics provide analogies, often brought into the discussion. Quantum tunneling, for example, is a well-documented process by which particles cross barriers they should not be able to surmount under classical rules. Instead of treating a wall as absolute, quantum mathematics frames it as a probability. A particle may remain blocked 99% of the time, but occasionally it appears on the far side without crossing through as we understand it. This effect is central in electronics, chemistry, and nuclear fusion inside stars. However, extending tunneling from atomic systems to macroscopic objects remains unsolved. Researchers note explicitly that the energies and coherence required to scale tunneling beyond small particles are immense, and current theory does not offer a path to send larger matter, let alone organisms, through barriers in the same way. Tunneling remains vital as an analogy, but it is not a finished bridge to human travel. Entanglement brings another piece to the discussion. When two particles are entangled, measurements of one instantaneously correlate with those of the other, regardless of the distance separating them. These correlations are consistently verified in laboratories today. Importantly, entanglement does not transmit usable information faster than light. What it does reveal is that quantum systems can remain linked across space in ways that defy classical locality. In that sense, entanglement serves as a model of connectivity for theorists. If microscopic systems can behave as if two regions are joined directly, then perhaps the geometry of spacetime itself allows for wider, hidden linkages. This is part of why wormholes and entanglement are often discussed together. These frameworks inspire further speculation about natural conditions. Some researchers have begun asking whether certain energetic alignments on Earth, strong magnetic fields intersecting with specific geological structures, or ionospheric currents folding against terrain, might incidentally mimic parameters that the equations for temporary wormhole stability seem to require. Modeling efforts have suggested that areas of concentrated energy could support short-lived wormhole-like effects in principle, though the parameters are exacting and no field evidence proves them. Importantly, mainstream theorists remain cautious. Experts emphasize the monumental energy required, the instability of any passage, and the lack of any known natural process capable of sustaining macroscopic wormholes. As particle physicist Matt Strassler and others stress, these constructs remain far beyond what particle colliders or natural Earth processes can achieve. Yet, the appeal of connecting physics with old legends persists. Cultures that marked specific stones, valleys, or mountain gates as sacred may have done so for reasons related to environmental anomalies they could sense but not explain. In modern terms, a geomagnetic fluctuation could still make compasses spin or electronics glitch. Centuries ago, such disturbances might have been experienced as a spiritual threshold. Whether correlated or not, the imagery of portals resonates strongly with the concepts physics now models in equations. Both describe connections bypassing intervening space, whether imagined in stories or charted in laboratories. The discussion often returns to the question of transmission. Even within simulations, what has crossed wormhole-like structures so far as data, bits of information? Could energy or larger structures ever traverse? Current theory places that far beyond reach. But the logic is incremental. If math supports data moving across a construct, then energy transfer becomes the next theoretical step, and matter after that. At each stage, the practical obstacles grow almost astronomical. Still, every incremental foothold pushes the idea away from pure conjecture. What seemed impossible now has a space on the map, even if the territory requires technologies many centuries removed from our own. Some speculative voices attempt to tie laboratory frameworks to disappearances or radiation anomalies reported in the field. Here caution is essential. Certain wormhole models predict short bursts of energy when passages collapse, suggesting that high-energy spikes might coincide with such events. But observed radiation fluctuations in remote regions have not been demonstrated to match these patterns precisely. For now, the overlap is intriguing but tenuous, a hypothesis in search of firmer data. Responsible researchers consistently call for reproducible monitoring, careful distinction between natural geomagnetic turbulence and any exotic explanation, and clarity about what theories do or do not predict. The divide between cautious theory and imaginative speculation keeps the conversation dynamic. On one hand, entanglement, tunneling, and simulation provide science with tangible mechanisms that faintly resemble the portal imagery of culture. On the other, practical physics demands enormous energy scales and stability conditions that Earth cannot currently provide. Experts insist that macroscopic, stable wormholes remain outside the range of our technology and may never be realized. Yet the fact that we can now model pieces of the puzzle in controlled machines demonstrates that something more than fantasy is at stake. For those tracing legends of gateways and disappearances, these developments bring scientific vocabulary to old mysteries. Where local accounts once spoke of thresholds and vanishing figures, physics now speaks of connectivity, tunneling, and probability. Without overstating the case, it is enough to recognize that these two languages occasionally point in a parallel direction. The next question, then, is how such speculative models are treated outside of universities and laboratories. When governments begin to examine whether unusual energy disruptions or spatial distortions should be taken seriously, the line between folklore, physics, and policy starts to blur. And that shift introduces a new dimension to the story: what has been documented in official files and how those records are shaping the wider debate. Government files and disclosure efforts since 2020. One of the most notable changes since 2020 has not come from fringe testimony, but from official channels releasing, or at least acknowledging, files tied to unexplained phenomena. For decades there were rumors of classified programs examining unknown aerial events, but in recent years a steady flow of official reports has made one thing clear. Governments now assign resources to study anomalies that remain unresolved by conventional physics or routine explanations. These are not late-night radio accounts or speculative blog reports. They are entries in public archives from agencies tasked with monitoring airspace and protecting national security. Between 2021 and 2024, multiple U.S. defense and intelligence offices confirmed the existence of anomalous observations affecting aircraft and sensors. The official language remained conservative. Terms like unidentified aerial phenomena, radar anomalies, or environmental distortion readings dominate the reports, but the descriptions still raise questions. Pilots described instruments deviating under calm conditions. Radar operators logged targets that seemed to displace, multiply, or vanish without technological signatures normally expected of aircraft. Instead of blaming these on simple hardware failure, analysts noted that the disturbances appeared tied to the environment in which systems were operating. The phrase, atmospheric and spatial anomalies, began appearing in unclassified summaries, indicating that the investigation considered the medium, not only the machines, as part of the problem. In some declassified documents, analysts used comparisons to astrophysical phenomena as a shorthand. Technical staff noted that certain sensor readings looked like weaker, local echoes of effects astronomers study in deep space, such as the bending of light when larger masses create a lensing effect. These comparisons were not presented as proof of that mechanism occurring near Earth, but as a way to describe unusual sensor behavior to readers familiar with physics terminology. Crucially, such analogies remain under study. They guide modeling, but do not establish that gravitational lensing is happening during military exercises. This is part of the guarded, precise tone marking government reports, allowing analogies for working models, while never confirming exotic conclusions. The narrative of leaked lensing documents gained traction in defense-watching communities online, but these are not accessible to the public through verifiable archives. What can be substantiated is the fact that classified and partially declassified records show repeated attention to unexplained sensor events. Those records demonstrate that anomalies were cataloged, compared year over year, and incorporated into training assessments, not ignored as one-off malfunctions. That ongoing tracking itself signals significance. If something appears often enough to be reported, logged, and studied, then it is treated seriously by defense agencies, even when no ultimate cause is given. The United States is not alone. In France, the official body known as GAIPAN, attached to the National Space Agency NIS, has kept a long-running database of unexplained aerial cases. While most reports resolve into familiar categories, GAIPAN acknowledges that a small percentage remain without clear explanation even after investigation. By keeping that category open, an official European government body effectively states that a fraction of reported anomalies still lack conventional understanding. Similarly, in 2022 and 2023 Canada launched Sky Canada Projects, a formal study surveying how citizens and pilots report UAP phenomena. One of its most important findings was not a sighting itself, but the confusion revealed in the public. Many witnesses did not know which government office was supposed to handle unexplained observations. The project recommended that Canada designate a central federal reporting authority, underscoring the need for structured transparency. This interagency activity broadened further in the United States with the creation of ARO, the All-Domain Anomaly Resolution Office, which coordinates between the Department of Defense and intelligence agencies. ARO's mandate includes collecting and analyzing UAP reports from across military branches, creating a consistent investigative process. While summaries released to the public remain cautious, their publication marks a departure from earlier decades of silence. By 2023, NASA also announced its own independent study task force into unexplained aerial events, emphasizing scientific assessment. NASA's entrance, pairing a science agency with defense offices, highlights how unexplained phenomena are now viewed as a legitimate subject requiring expertise beyond military training. The cooperative framework between NASA, ARO, and other federal offices extended into related areas like space, weather monitoring, and atmospheric study. This linkage is not evidence that portals exist in the traditional sense, but it does show that governments now see value in comparing data across multiple domains: cosmic radiation, geomagnetic disturbances, and localized flight anomalies. Official explanations emphasize hazard identification, ensuring that equipment, pilots, or satellites are not endangered by unfamiliar environmental conditions. Even so, the widening net catches data that inevitably overlaps with subjects long relegated to myth. For observers outside government circles, the fact that official agencies track anomalies in detail fuels the impression that state institutions are quietly acknowledging the same mysteries recorded in folklore. It is essential to underline the limits of this disclosure. Governments investigate because unexplained phenomena can affect safety and security, not because they endorse exotic interpretations. Classifying documents and logging anomalies does not mean officials conclude that dimensional doorways exist. It means that, from their perspective, any repeatable unexplained disruption to sensors or equipment must be taken seriously, regardless of origin. Critics of speculation stress this distinction. Interest and investigation are not confirmation. A recurring radar glitch could be natural technological interference or something we do not yet understand. All possibilities remain open until evidence narrows them. Yet the steady publication of official reports has already shifted the cultural ground. For decades, unexplained aerial sightings or strange environmental disruptions were treated as fringe topics. Today, formal offices, budget allocations, and public hearings confirm they are at least unresolved military and scientific questions. Even without providing final answers, governments have legitimized the anomalies by embedding them in official procedure. They are no longer rumors. Now they are line items in bureaucratic planning, studied alongside recognized national security risks. Some of the most telling developments have occurred not in what was said, but in what was recommended. Canada's Sky Canada project advised establishing a single federal office for collecting and analyzing citizen and pilot reports. That recommendation highlights what many researchers and the public most want: a transparent pathway for information, where reports are not scattered across disconnected agencies. A centralized channel with consistent data collection would allow both scientists and policymakers to detect patterns, raise public confidence, and reduce the confusion that currently surrounds unexplained sighting reports. The movement toward transparency, however gradual, is what keeps this subject evolving. Governments may not declare contact with other realities, but by acknowledging anomalies and assigning agencies to them, they confirm the phenomena are real enough to count in national data. This measured disclosure builds a foundation, one that shows interest is serious and backed by accountable institutions. Each public release, survey, and hearing reinforces that foundation, hinting that more comprehensive data may follow if formal channels are strengthened. The significance for viewers lies in understanding where myth meets record. Ancient stories spoke of gateways and thresholds. Modern files now describe environmental anomalies logged in official defense and aviation reports. Between them is continuity, a human effort to recognize that something unusual registers in both human experience and instrument data. The difference today is that instead of legends alone, we now have governments systematically archiving the event logs. That transition alone is historic, giving the subject a legitimacy it has rarely held before. The underlying problem remains unresolved. The absence of consistent explanations leaves investigators without a clear framework. Governments classify for caution, not proof. Researchers model analogies, but they stop short of claiming verified mechanisms. Citizens report encounters, but many still hesitate to whom they should turn. The call for transparency, such as the Sky Canada recommendation, marks the most productive next step. By improving how these reports are gathered and studied, the confusion can gradually give way to reliable datasets. With enough of those, patterns could emerge that clarify whether anomalies stem from natural forces, new technologies, or something more difficult to categorize. And it is precisely the possibility of patterns, recurring alignments of disappearances, electromagnetic fluctuations, and portal legends, that draws investigators into the next frontier. Officials may describe anomalies in careful technical language, but researchers outside government are beginning to chart them in surprising ways, searching for signals in the distribution itself. Statistical mapping of global portal hotspots. When discussions expanded beyond government files, a question arose. If anomalies truly leave traces on the landscape, can we chart them with the same tools we use for any other pattern? This led to a growing interest in what some researchers and citizen groups have called the statistical mapping of portal hotspots. Instead of treating individual disappearances, electromagnetic oddities, or ancient sites as disconnected, people began overlaying them to see if any geographic clusters stood out. The idea itself is compelling, though it is important to emphasize that what exists so far are exploratory overlays and hypotheses, not formal peer-reviewed confirmation. Early attempts circulated in independent publications between 2022 and 2024. Participants collected three main categories of data: missing person reports filed under unusual circumstances, maps of electromagnetic disturbances drawn from satellite records, and global coordinates of ancient ceremonial or monumental sites. When plotted separately, each set showed familiar patterns, but when overlaid, certain regions emerged as recurring nodes. To those studying the correlations, the results looked less like random scatter and more like converging layers of evidence. Still, without controlling for confounders such as local population density or the history of reporting, these maps remain best described as suggestive. They raise questions worth investigating, but they cannot yet claim authority. For recurring clusters became especially well known in popular and independent surveys. The first was the Peruvian highlands near Lake Titicaca. Already part of myths surrounding gateways carved in stone, the region also has a density of archaeological remains aligned with astronomical events. Local and international reports describe unusual instrument readings there, though much of the material appears in journalistic or folkloric sources. The second cluster is in northern Arizona, centered on Sedona. Tribes long described it as a place of strong energy, and more recent tourism reinforced its image as a vortex zone. Independent magnetometer readings from amateurs claimed anomalies, though systematic studies are scarce. Another area often flagged is the Ural Mountains in Russia. The region is remote, subject to harsh weather, and host to enduring mysteries, including accidents involving explorers and references to stone arrangements that locals describe as ritual sites. When enthusiasts mapped disappearances alongside reports of aircraft experiencing navigation trouble, the Urals stood out once more. A fourth recurring zone lies across the Gobi Desert of Mongolia and northern China. Here population density is low, and records of disappearances are harder to match. Still, electromagnetic readings gleaned from satellite data show spikes comparable to those in regions with denser folklore. These four zones, Peru, Sedona, the Urals, and the Gobi, do not constitute scientifically proven supercenters. They simply appear in multiple informal overlays, enough to suggest that they deserve careful, peer-reviewed field work. The natural question is why these particular regions consistently reappear, while many others do not. One hypothesis points toward the ways Earth's magnetic field interacts with solar activity. The magnetosphere is not constant. It flexes and distorts as energy from the sun surges or calms. During high activity, disturbed zones can experience interference more strongly. This is well documented in space physics, where auroras and satellite communication disruptions correspond with solar storms. For hotspot proponents, the intriguing observation is that anomalous readings in places like Peru or Sedona seem to intensify during solar peaks. But the challenge is separating genuine anomalies from the normal lifts and falls of geomagnetic variation that occur worldwide. Without robust controls, the appearance of special sites could simply mirror general increases in solar turbulence. Several groups produced heat maps in 2023 and 2024, tracing where these magnetic pulses seemed strongest. To enthusiastic interpreters, the maps showed activation windows that resembled folklore stories about doors opening and closing. Critics warned that any mapping must account for confounders. Densely visited regions naturally generate more reports, while remote areas may go unrecorded even if conditions are identical. Tourist activity also biases the collection. Since locations marketed as vortex, zones attract more people who notice odd events. Responsible analysis must address these variables before arguments about genuine clustering are made. Machine learning has also begun to appear in this work. Independent groups experimenting with AI-used programs to compare weather records, electromagnetic data, folklore site catalogs, and missing person reports. In some test runs, these models highlighted correlations that researchers found interesting. A few even tried limited forecasting, suggesting where anomalies might flare next. At present, these experiments are exploratory demonstrations at best. No published peer-reviewed study has verified that AI can operationally predict anomaly risk with accuracy. The realistic description is that machine learning is being tested as a correlation tool, not a forecasting engine. Even with these limitations, the overlays have drawn attention because of the layered structure they reveal. Each contributing dataset, folklore, electromagnetic reading, disappearance log, remains incomplete. But when combined, they create patterns that captivate communities searching for evidence. The effect is one of momentum, where imperfect information takes on a sense of coherence. That coherence could either reflect genuine underlying phenomena or collective projections shaped by expectation. Distinguishing between the two requires stronger field evidence and scientific review. Some of the more cautious analysts emphasize the importance of treating these overlays as starting points. If a cluster emerges in amateur maps, it can direct official research teams to test the area systematically. Field surveys with well-calibrated equipment could assess whether electromagnetic shifts there truly differ from baseline. Archaeological collaborations could clarify how ancient structures align with natural markers or sky events. Importantly, disappearance data would need verification from official case records before being entered into causal studies. Only when these threads are validated can claims move from suggestive to substantive. Given the contested ground, what role can an audience play in this exploration? One path is engagement. Citizens reporting unusual readings from handheld instruments or noting geographic coordinates of unusual light phenomena. When aggregated responsibly and checked against scientific baselines, citizen inputs could create valuable supplementary data. Another path is skepticism, recognizing how anecdote and probability can mislead and pressing for controlled studies. Viewers following these investigations should balance curiosity with critical assessment, asking what factors might bias a map before accepting any claim of supernatural clustering. The conversation around hotspots underscores both the risks and the promise of seeking patterns. Risks arise when scattered anecdotes are treated as proof, leading some to claim far more than the evidence warrants. Promise emerges when clusters suggest directions where science and archaeology could fruitfully devote resources. If attention is disciplined, informal overlays could act as guides that shape the next generation of field studies. If attention is careless, they risk reinforcing myths without moving closer to truth. By 2025, the consensus among responsible commentators is that portal hotspot mapping remains an intriguing hypothesis in need of rigorous verification. The overlays are suggestive, not conclusive. Peru, Sedona, the Urals, and the Gobi continue to appear in multiple datasets, but until peer-reviewed field campaigns confirm the anomalies, they must remain open questions. Still, their persistence draws interest, and their cultural weight ensures they will not fade from public discussion. What matters now is how these tentative maps intersect with direct measurement. Clusters on paper are one thing, reproducible signals in the field are another. The critical next step is testing whether modern instruments can capture signatures that align with what folklore and overlays suggest. If they can, the conversation moves from circumstantial patterns to empirical evidence. And it is precisely here that the newest stage of the story begins, where the tools of science are aimed at detecting what earlier cultures may have sensed without machines. Modern technology detecting hidden gateways. Modern instruments now form the center of the discussion about whether hidden gateways can be detected at all, moving the subject from folklore into defined protocols of field study. For centuries, traditions told of thresholds sensed in ritual or trance, but these impressions could not be measured. Beginning in the early 2020s, however, advances in imaging and remote sensing allowed teams to document subtle variations in terrain and electromagnetic fields. What shamans once described through vision or ceremony can now be explored through recorded data. Technology does not confirm portals as literal doorways, but it provides tools to assess whether recurring anomalies exist at the sites legends long emphasized. One of the most widely used technologies is ground-penetrating radar. Originally designed for geophysical surveys and archaeological excavation, GPR sends radio pulses into the earth and captures the reflections to map underground features. Its growing resolution makes it possible to chart not only foundations and tombs, but also cavities and fissures hidden within solid rock. Applied around ceremonial sites in Peru, Mexico, and Central Asia, surveys have revealed empty chambers and voids that earlier surface inspections overlooked. Independent teams have pointed to some of these findings as aligning with mythic gateway locations. The caution, though, is that such surveys are preliminary. Radar anomalies may represent natural fractures or density shifts, and they require peer-reviewed excavation to confirm. Without follow-up, claims of tunnels or hidden sanctuaries remain speculative. Above the ground, Lidar scanning has become a complementary tool. By sending rapid pulses of laser light and measuring their reflection, Lidar strips away vegetation cover in digital models, exposing buried architecture and long-forgotten alignments. Archaeologists have mapped extensive city grids in Central America with these methods. At sacred sites said to mark thresholds, Lidar sometimes reveals precise geometric alignments that correspond with astronomical orientations. To some, this suggests ancient builders selected landscapes with knowledge of unusual features, while others see cultural symbolism carried out through monumental design. Either way, Lidar adds detail impossible to perceive through earlier mapping, and when paired with GPR results, it frames the terrain as layered rather than static. Magnetometry adds a third dimension to modern surveys. Instruments refined in the last decade can now detect changes of a few nanoteslas, far below the sensitivity of compasses. Used across suspected sites, they reveal localized patches where the geomagnetic field shifts unexpectedly. Independent expeditions claim that these shifts sometimes appear in narrow bands, creating the impression of edges in the landscape. Such traces match oral motifs about thresholds or invisible walls only a step from normal ground. The problem is that data varies sharply between teams, equipment, and conditions. Without standardized replication, no survey can decisively prove a stable anomaly. Researchers emphasize the need for carefully published field reports so results may be reproduced elsewhere. Some investigators now combine these techniques. A survey might deploy GPR for subsurface voids, Lidar to confirm above-ground alignments, and magnetometers to record electromagnetic fluctuations. If all three instruments register anomalies at the same coordinates, the weight of evidence increases. Yet without replication by independent teams, a single project cannot be considered conclusive. This emphasis on method echoes official recommendations in other fields. Canada's Sky Canada project, for instance, reviewed unexplained aerial phenomena and concluded that a major obstacle is fragmented reporting. Witness accounts and technical data are scattered across multiple bodies. The solution proposed was a central channel to integrate information. Applied to portal studies, the lesson is straightforward. Detection only gains meaning when data from multiple instruments is coordinated, archived, and subject to standards of verification. Satellite technology now contributes to this effort. Advanced magnetic and gravitational sensors aboard research satellites capture changes across Earth's field with high precision. Some citizen researchers cross-reference these patterns with ground-level magnetometer readings at well-known gateway sites, hoping to find matches. Hints of correlation generate interest, but scientists remain cautious. Many environmental factors influence Earth's field, from ionospheric currents to solar storms, and distinguishing genuine local anomalies from background variation requires rigorous filtering. Still, the availability of global datasets opens the possibility of testing ancient claims against continuously recorded measurements. As instruments extend abilities once confined to geophysics and archaeology, their deployment across traditional gateway sites keeps growing. Drones carrying multispectral cameras hover over monuments to capture changes in light or heat distribution. Portable sensor arrays measure electric and magnetic fields along ridges. Satellites deliver streams of gravitational and radiation data daily, feeding into databases mined by AI for correlations. Each step adds another layer of documentation. What centuries ago sounded mystical is now subject to charts and printouts. The main limitation is not the absence of data, but the lack of coordinated review that transforms raw readings into reliable knowledge. Interpretation remains conservative. A magnetic spike or subsurface void does not prove an interdimensional aperture. It only shows that a site is physically complex, worth more sustained attention. As analysts emphasize, credibility depends on replication and method. One instrument recording an anomaly on a single day is insufficient. What gains traction is consistent detection across multiple surveys, cross-verified by independent teams, and tied to environmental controls. This standard mirrors the scientific process in every field. Reproducibility transforms speculation into evidence. Linking these results with cultural history reinforces the importance of careful analysis. Oral traditions describe dizziness, visions, or sounds in specific landscapes. Modern instruments sometimes chart irregular magnetic behavior at those same coordinates. But coincidence does not establish cause. A geomagnetic shift may produce psychological sensations, or it may simply coexist with cultural memory. Clarifying that link demands more than intriguing overlap. It requires controlled experimental work testing how human physiology responds to such fields, measured under conditions that rule out subjective bias. This is the frontier where folklore and instrumentation might be reconciled, but only with studies designed to meet scientific thresholds. The policy angle is equally important. Without consistent protocols, reports remain fragmented. Sky Canada underscored this issue when surveying how pilots and citizens report unexplained aerial events. People often had no idea which office to contact, and data was lost. Portal research faces a similar challenge. Separated logs from drones, satellites, and field surveys risk dispersal unless centralized frameworks collect them. A coordinated repository would not prove anomalies exist, but it would let scientists evaluate them systematically. A layered archive could also test whether stories of concentrated anomalies reflect genuine recurrence or chance clustering. What stands out most in 2025 is not a single discovery, but the growing integration of technology with questions once left to myth. Instrumentation is now part of the inquiry, providing measurements where earlier investigations had only folklore. Yet scientific standards remain vital. Replication, publication, and peer review determine which anomalies enter the record. It is in this tension, between a steady pile of raw readings and the rigorous procedures needed to interpret them, that the study continues. The natural question emerging from this intersection is how much ancient builders understood of these same landscapes. If modern instruments detect unusual alignments and fields only now, what guided earlier civilizations to carve their monumental gateways at these precise locations? That is the puzzle history leaves behind, and it leads directly to the next layer of the story: ancient civilizations and advanced knowledge. Many scholars point out that monumental sites were not placed at random, but instead chosen with care. This brings forward the theme of ancient civilizations and advanced knowledge. Across multiple cultures, constructions often rise at locations that modern instruments now note as unusual, whether through subtle geomagnetic variation, geological faulting, or astronomical alignment. To explain this overlap is challenging. Civilizations did not have magnetometers or satellites, yet many appear to have selected places that today show measurable peculiarities. The most balanced explanation is that builders responded to what they could perceive directly: landscapes that felt different, skies that aligned precisely, or sensations produced in particular valleys and ridges. The suggestion that ancient people engineered electromagnetic portals remains unsubstantiated, but it is harder to dismiss the impression that site placement reflected deliberate observation of both earth and sky. In the Peruvian highlands, megalithic complexes exemplify this. The structures display clear solar and equinox alignments that are widely accepted by archaeologists as intentional astronomical design. At the same time, compasses brought to these areas sometimes behave unpredictably. When researchers detect swings in magnetic instruments today, they highlight coincidences that the ancient people may have noticed in other ways: physical sensation, animal behavior, or repeated ritual experience. If locations reliably produced dizziness, tingling, or auditory changes, communities might have judged them sacred or exceptional. Stones carved and placed there would serve not only as ritual markers, but as enduring signals of landscapes unlike the surrounding terrain. A similar duality surfaces in Egypt. Temples that line with Orion or Sirius also happen to stand near subtle geological faults. Measured shifts in magnetic readings trace along those same fractures. Archaeologists traditionally interpreted Egyptian orientation in terms of symbolic cosmology. Temples channeling stellar power, axes linking to heaven. Some current researchers cautiously add a second layer. Aligning with stars may have been a strategy for identifying terrestrial points of special significance, fault lines, changes in groundwater, or geomagnetic variations. Without writing that proves this, it remains speculation. Still, the overlap of stellar precision and geological irregularity suggests that temples anchored both celestial narrative and terrestrial energy in ways the Egyptians experienced, even if in forms we cannot reconstruct completely. India provides further parallels. Legends tell of sealed doorways in ancient temples, sometimes described as thresholds not to be opened until future ages. Pilgrims at these sites report sensations of heaviness or striking acoustic resonance within corridors. Modern geomagnetic surveys have charted deviations near some of these structures. Linking ritual architecture to measurable anomalies again cannot be declared definitive, but it raises questions about whether sensory impressions of the environment guided temple placement. For those traditions, the connection between unusual sensation and sacredness was self-evident. For modern science, it is a dataset in need of careful replication. Sound consistently appears in legends of these spaces. Chants, gongs, or flutes are recorded across diverse regions as tools that activated or interacted with built stone. The motif surfaces in South American accounts tied to carved recesses, in Himalayan rituals where gongs resonate for long periods, and in desert sites where bone flutes were sounded beside enclosures. The idea that resonance interacted with landscape rather than serving worship alone forms a striking thematic thread. From a modern standpoint, some field studies have explored this possibility. Teams have tested carved stones with controlled tones, recording resonance effects with microphones, accelerometers, and magnetometers. In a few cases, instruments displayed brief changes in local electromagnetic field strength when subjected to particular vibrations. These pilot studies require replication, peer review, and institutional oversight before any conclusions become strong, but they show that the motif of sound and landscape interaction is testable rather than purely mythical. One often cited example occurred in Peru in 2022. Researchers imitated traditional notes described in oral traditions near certain stone carvings. Their equipment registered resonances different from simple hollow echoes. Layered harmonics stretched across broad ranges. During those intervals, magnetometers recorded short-lived amplification of field strength. The spikes did not persist and were not universally reproducible across the region, but the suggestion remains intriguing, that shaped recesses and sonic input might couple in ways not fully understood. The importance of this study lies not in declaring ancient gateways opened by sound, but in demonstrating that structural acoustics can produce measurable, if transitory, electromagnetic responses. The implication is that ritual sound could have coincided with natural variations to produce environments that felt deeply altered. Whether these experiences were neurological, physiological, or in some way geophysical is still unclear. Cultures encountering such events would interpret them through myth. Beings passing through stone, or thresholds opening in vibration, could represent how ancestors made sense of amplified perceptual effects. For them, repeated outcomes confirmed the site's importance. For us, The overlap across different traditions highlights a phenomenon worthy of closer scientific attention. It matters that many cultures independently associated ritual sound with their monuments. In South America, drumming beside carved gates. In Asia, bells and chants ringing through temple corridors. In the Near East, horns blown at sanctuaries. All suggest that sound was central to the ritual environment. From a cautious standpoint, these practices may have incidentally stimulated or interacted with features of the landscape, though without deliberate technical understanding. Modern research has only begun to measure whether acoustic practices alter nearby fields or resonance patterns. Even if results prove inconsistent, they illustrate how past traditions may have registered genuine physical effects through sensory experience without ever formalizing them as scientific theory. Accounts from the Aymara, near the Gate of Aramu Muru, tie this together. Oral traditions recorded over generations describe priests stepping into the rock niche as if entering water, guided by music or chanting. Cultural custodians of the site today caution that it must be treated with respect, echoing beliefs in its potency. Such narratives provide a valuable counterweight. They root speculation in voices still present, reminding us that any discussion of thresholds belongs at once to myth, heritage, and lived practice. When modern sensors record anomalies nearby, the overlap adds an additional layer, even if no single measurement proves extraordinary claims. A balanced interpretation, then, is not that ancient civilizations engineered electromagnetic portals or shared a universal global technology. Rather, they consistently observed and marked places where the physical world felt altered and integrated sound and architecture into their rituals. Sometimes those places also register anomalies to modern instruments. The overlap is compelling, but the mistaken leap is to assume deliberate portal construction. Instead, what stands on firmer ground is recognition of a sustained relationship between cultural practice and environmental sensitivity, insight into landscapes that modern science is only beginning to test more systematically. As exploratory studies continue, we are left with a layered picture, monuments aligned with the heavens, situated on geologically active sites, and enveloped in ritual sound. Each of these layers carried meaning for the builders of the time. Today, their convergence raises questions about perception, environment, and the boundary between myth and measurable effect. It is a subject where the cautionary voice of science coexists with the imaginative reach of culture. This tension between architecture, field evidence, and story sets the stage for the next step in inquiry. If ancient traditions and modern instruments both point toward unusual experiences at certain sites, the natural question becomes, what do contemporary witnesses say when they encounter them? That is where the account now turns, moving from ruins and measurements into the testimonies of people who have directly reported what they believe are passages into other realms. First-hand reports of dimensional travel, 2020 to 2025. From 2020 onward, the conversation shifted from ruins and legends to something more immediate. People alive today describing moments they believe involved stepping outside normal space. These first-hand reports are often accompanied by logs from GPS trackers, flight instruments, or cameras. They are fragmentary and circumstantial, but they have attracted attention because in several cases more than one device or observer records unusual effects at the same time. Investigators emphasize that these incidents do not prove dimensional travel. They instead provide leads, puzzling overlaps of human testimony and partial data, that warrant closer examination by independent authorities before any strong conclusion is drawn. In the Andes, for example, multiple trekking groups between 2020 and 2024 described sudden shifts in light and time. Individuals reported clear morning skies dimming instantly, with shadows stretching unnaturally, and then memories skipping as though minutes had vanished. The obvious explanation would be exhaustion or altitude sickness, both common at high elevations. Yet some participants wore GPS watches and activity monitors. A few of those devices recorded abrupt coordinate jumps, positions moving miles ahead in fractions of a second. Hikers claimed they could not account for the skipped distance when retracing their route. These logs are striking but remain anecdotal, as GPS devices can experience signal multipath errors or sudden dropouts in mountainous terrain. Without independent review of the raw files and chain of custody verification, no claim of extraordinary passage can be made. Pilots have also described perplexing encounters. Beginning in 2021, small craft flyers in western Nevada and parts of the Urals noted stretches where their instruments appeared to lose coherence. Altimeters oscillated wildly, compasses spun, and satellite navigation struggled to hold a fix. In one well-circulated account, a pilot described seeing a haze, an opaque sheet rather than recognizable weather. During the same interval, his tracking system later appeared to register a jump in mileage inconsistent with the aircraft's fuel burn and engine speed. To aviation authorities, such an event demands caution but not exotic explanation. Radio interference, brief satellite dropouts, or unrecognized weather fronts can disrupt electronics. The broader interest arises because such reports fit within a cluster of similar accounts where instrument irregularities appear together with subjective impressions of missing distance. These remain investigatory leads, not verified cases of anomalous travel. Accounts from remote Siberia added another layer. Explorers in 2022 described walking through forest terrain, only to look up and find themselves beside a riverbank kilometers from their starting point. Wearable devices showed a discontinuity, with location markers jumping without intermediate data points. For those involved, the event felt disorienting, like a blackout followed by sudden relocation. Critics caution that GPS corruption in dense tree cover is well documented, particularly in areas where satellite signals reflect off terrain. The absence of continuous readings does not equate to unusual physics. It is precisely the kind of environment where data gaps are common. Yet what intrigued researchers is not one faulty trace, but multiple accounts repeating the same basic features. Sudden absence of normal memory, unexpected new position, and data logs with irregular jumps. Even as speculation abounds, investigators agree that without controlled instrumentation, these anecdotes cannot progress beyond circumstantial evidence. A particularly notable attempt at a controlled environment took place in Arizona in 2023, when a research group established a small monitoring camp near a canyon ridge. Volunteers were equipped with GPS, biometric trackers, and body cameras before walking prearranged loops. In one trial, a subject's coordinates appeared to move several hundred meters with no time interval registered. External cameras briefly glitched, showing a half-second blur. The participant later reported a sensation of luminosity or blankness during the interval. On paper, such convergence sounds dramatic. In practice, it remains inconclusive. Instrument systems must be independently calibrated, handled under strict chain of custody, and their findings reproduced by other teams before they can count as evidence. Otherwise, the most that can be said is that one experiment provided material worthy of follow-up. The subjective accounts themselves are often startlingly similar. Many speak not of darkness or other landscapes but of whiteness, an empty haze where surroundings dissolve before reappearing elsewhere. People recall an absence of texture, as though the environment turned featureless. These similarities, repeating across hiker narratives, pilot testimony, and explorer reports, echo descriptions in old myths that spoke of doors of light or thresholds that appeared as blank space. From a scientific standpoint, repetition of imagery across independent witnesses is notable. Yet without physical evidence, it does not establish external phenomena. It suggests instead a shared psychological or perceptual effect encountered in moments of disruption. Phenomena worth investigating further, but not conclusions unto themselves. Skeptics reinforce that all instrument irregularities could result from mundane failures. GPS logs are vulnerable to multipath reflections from cliffs, magnetometers can spike during solar storms, and cameras often glitch under dust or rapidly changing light. The fact that errors can line up across devices at the same moment might surprise lay audiences, but experts regularly caution that related systems share vulnerabilities to the same environmental stresses. What gives the current reports weight is only their redundancy, overlapping testimony and overlapping logs that align to an unusual degree. This alignment merits study, though it still falls short of confirmation. To strengthen credibility, researchers outline what independent verification would require. First, synchronized arrays of instruments, GPS, magnetometers, radiation sensors, must be deployed together, with timestamps locked to verified atomic clocks. Second, devices must be handled with documented chain of custody, so data cannot be altered after the fact. Third, field findings must be immediately backed by physical evidence, marked positions, ground samples, or telemetry uploaded to independent servers in real time. Only with layers of documentation can anomalies be judged extraordinary, rather than artifacts of human error or equipment limitation. The human side, however, continues to expand outside controlled studies. Reports are common, But what often goes unrecorded is just how many people experience anomalies yet never report them officially. In 2023, Canada's Sky Canada project surveyed citizens on their experiences with unexplained aerial phenomena. Roughly 27%, about 1 in 4 Canadians, reported having seen something they regarded as a UAP. Yet only about 10% of that group said they reported the sighting to authorities. The result demonstrates both the volume of lived experiences and the gap in official documentation. For every well-publicized account of strange relocation or anomalous light, there may be several that remain unspoken or confined to personal journals. This underreporting means researchers often work with a partial picture, amplifying the importance of formal channels for recording testimony. That distribution of unreported experience might echo in the context of alleged dimensional travel. For every hiker carrying a GPS wristband, dozens walk those trails without devices. For every pilot logging through official channels, others may remain silent, reluctant to face questioning. The overlap between underreported aerial sightings and underreported anomalous travel suggests that current databases capture only a fraction of the events people believe they have encountered. Building confidence through transparent, centralized reporting, something Sky Canada recommended as necessary, could improve the evidentiary base enormously. Still, it is important to underline the provisional status of all these accounts. No peer-reviewed publication has verified instant relocation or space compression in humans. No controlled, reproduced experiment has demonstrated traversal across dimensional thresholds. What we possess are personal narratives supplemented by inconsistent data lapses, intriguing enough to study, but not strong enough to accept as proof. The reliability of memory, the fallibility of instruments, and the vast size of the datasets required all complicate interpretation. Maintaining this balance between respect for witnesses and caution about claims is the most rigorous path forward. Taken together, the Andean hikers, the Nevada pilots, and the Siberian explorers form a mosaic of anecdotes stitched with thin seams of data. Their descriptions overlap, their devices occasionally echo the same themes, and older legends resonate in the background. Yet until validated by independent authorities with robust methodology, these must be regarded as investigatory leads rather than confirmations. The stories retain power because they linger unresolved and because official reporting structures remain incomplete. The accumulation of testimony points towards something broader. It may be coincidence, error, or environmental effect, but people across continents continue to report sudden absence, distorted time, and impossible travel. Viewed one by one, such stories can be dismissed. Viewed together, they challenge us to ask if they reflect pieces of a larger structure we do not yet recognize. And it is at this shift, from puzzling isolated anomalies to the possibility of a wider framework, that the next stage of inquiry emerges. The bigger picture, evidence of a multiverse reaching us. The question that naturally emerges is whether all these scattered cases, instrument glitches, folklore of thresholds, and anomalies in the field, fit into something larger than coincidence. This is where the conversation has turned to the bigger picture, framed by a model that imagines reality itself as layered. In 2025, physicists revisited multiverse frameworks not as confirming evidence of neighboring worlds we can walk into, but as theoretical models that outline how one universe might coexist with others in ways we could test. From this angle, portals are no longer depicted as permanent gateways, but as hypothetical points where boundaries between domains might weaken for an instant, letting interactions occur. One popular way of explaining these ideas is the nesting analogy. Imagine Russian dolls stacked inside each other. Each doll is distinct and whole, yet part of a set. Similarly, in some models of physics, each universe is self-contained but folded adjacent to others, sharing a layered geometry. This image helps explain how boundaries can preserve separation, yet still touch under specific circumstances. A portal in this framework might not be a tunnel cut across galaxies, but instead a momentary seam where one layer brushes another. For people in past centuries encountering strange sensations or light, the experience of moving sideways into an adjoining layer could be remembered as crossing into the land of spirits or gods. The mathematics behind this is complex, yet the principle is clear. Equations in quantum cosmology show that space may contain folds where other structures press close. Abnormal signals, like sudden spikes in background radiation or conflicting geographic coordinates, are sometimes treated as candidate traces of these folds. Importantly, Physicists caution that this is a model under active debate, not a verified phenomenon. Equations can predict where anomalies might appear, but they do not demonstrate that a traveler has shifted between universes. At their most cautious, scientists describe these scenarios as testable hypotheses, valuable because they generate predictions future experiments can try to confirm or refute. Momentum toward this layered picture arises partly from laboratory simulations. With quantum computers now able to mimic specific conditions, researchers have constructed small systems behaving according to wormhole equations. In some simulations, information introduced at one side of the construct appeared to re-emerge on another without intermediate transfer. These results are significant not because they build real wormholes, but because they demonstrate that the mathematics of crossing boundaries produces consistent, reproducible effects in a machine. The utility of the model is clear. If digital systems can imitate boundary behavior on a small scale, then natural environments might, in theory, reflect similar principles. That does not mean an actual human crossing has been shown. It simply extends the scope of questions science can now pose in measurable terms. Beyond computing labs, attention has turned to older accounts that describe sudden vanishings or altered flows of time. These are not treated as proof, but as qualitative records that may overlap with the predictions of modern theory. In India, South America, and the Mediterranean, stories of sacred doors and shimmering thresholds remain attached to locations where unusual readings have since been claimed. Pilots and hikers in the last 5 years describe encounters with blank expanses or sudden coordinate jumps. Defense reports cautiously catalog sensor distortions at testing ranges. Citizen mapping projects chart repeated geographical clusters. None of these stand alone as decisive, yet their convergence makes the nesting model appealing as a framework. It offers a way to organize disparate data into a coherent research program, rather than leaving each observation isolated. Skeptics raise important objections here. Is it legitimate to set folklore beside quantum simulations, treating both as evidence? Or does that risk collapsing wildly different categories into one? Advocates respond that alignment does not prove causation, but it can guide inquiry. 3 streams: mathematics that predicts seams, traditions that describe thresholds, and scattered modern anomalies, together identify areas where careful study might be justified. The value lies in treating them as hypotheses to be tested, not as confirmation that layered universes intersect our own. Consider how the nesting model reframes scale. Instead of giant wormholes requiring astronomical engines, it proposes small distortions at localized points where boundaries fold together. The crossing would not involve dramatic spectacle but shifts that feel subtle. Haze, silence, loss of orientation. Witness narratives describing blank corridors or missed stretches of time fit this imagery more naturally than epic science fiction renditions. Yet again, the caution must be clear. Similarity of description does not establish reality. The logical chain is hypothesis only. Proving contact between universes would require evidence far stronger than what exists. For investigators, decisive proof would look like reproducible events captured by arrays of calibrated instruments, witnessed independently by multiple observers, published and replicated across research teams. At present, no case meets these standards. GPS drops, flickering cameras, or magnetometer spikes provide fragments, but not complete chains of verification. Until such conditions are fulfilled, cross-universe passage remains an idea, one that scientists can model, but not claim to have observed. Even as proofs remain absent, the interdisciplinary convergence has had a tangible effect. It shapes where resources are directed. Physics proposes nested models. Archaeology provides sites with long-standing ritual significance. Technology supplies sensing and mapping tools. Each piece adds to a program where testable predictions are developed. That anomalies should appear at coordinates aligned to specific geology, or during periods of intense solar activity, or in regions long considered sacred by oral tradition. What these predictions accomplish is not final proof but practical guidance for fieldwork, ensuring data collection is focused where the hypothesis suggests signals might cluster. Seen from another angle, the historic value lies in reframing cultural memory. Myths once dismissed as imagination can be reinterpreted as records of repeated experiences, filtered through spiritual language. A recurring perception of thinned boundaries might retain meaning even if the physics behind it remains obscure. For modern researchers, This is not evidence of engineered portals, but an archive of human experience flagging sites worthy of fresh measurement. The payoff is less about confirming myth wholesale, and more about recognizing its utility as a long-term qualitative dataset. In this context, portals become less about certainty and more about opportunity. The Russian doll analogy, while simplified, provides a mental model through which to imagine layers that sometimes press together. Physics supplies the mathematics, folklore preserves witnesses of altered states, technology hunts for environmental traces. None proves the existence of doors into other universes, but together they offer a coherent research path forward. Hypotheses that demand testing, not faith. The intellectual value comes from holding the tension between speculation and restraint. Models in cosmology are developing rapidly, producing new equations and heuristic images. Real anomalies continue to be reported by citizens, pilots, and expedition groups. Ancient markers keep surfacing in alignment with today's instruments. Interdisciplinary attention brings these diverse sources into dialogue. The outcome is not proof of a multiverse brushing against ours, but the recognition of a fertile field of study that joins physics, archaeology, and atmospheric science under a common theme. Looking ahead, the layered universe analogy may serve as a practical guide. By treating our world as one doll within a stacked series, researchers gain a structured way of deciding which sites to monitor, which environmental conditions to prioritize, and how to design future quantum simulations. Its strength is not in final proof, but in the way it organizes attention and delivers testable questions. For a research agenda that has often seemed fragmented or speculative, that is already a significant achievement. What would transform speculation into established science remains clear: reproducible, instrumented, multi-witness events, recorded across independent systems and laboratories. Until then, the nesting model stands as a provocative but unconfirmed hypothesis. Yet its usefulness lies in the direction it gives, not to claim discovery, but to design the next round of investigations. And that brings us back to the question animating this entire exploration. Across physics, folklore, and technology, a picture is forming where thresholds are no longer dismissed, but investigated cautiously within a broader model of layered realities. What that means for how we think about our place in the cosmos is the step we now face. In 2025, the subject of portals sits in a new place, no longer confined to myth, but not yet confirmed by science. Physics, archaeology, and remote sensing tools all point toward patterns worth studying, yet none provide proof of extra dimensions. What we have are growing questions, not final answers. Stones and sites that once carried only symbolic meaning now appear at locations where instruments do register irregularities, but replication and peer review remain essential before any conclusion is justified. If anything ever crosses, it would reshape everything, so science will pursue the data, not the drama. 2025 leaves us suspended between two truths: more instruments and reports than ever before, and fewer definitive answers than curiosity demands. If you have local stories, questions, or experiences, add them in the comments. Subscribe if you want to follow how verified studies unfold. For reference, check the description links to the Sky Canada review and recent physics papers, sources that underline a key point: rigorous inquiry values replication over speculation.